Hello, good morning. Let us start lecture number 3 on vector algebra. In this lecture, we will study addition of vectors. We will study triangle law of vectors and parallelogram of vectors. So let us start with triangle law of vectors.
We'll go to addition of vectors. First we'll see triangle law. Triangle law. If two vectors are represented in magnitude and direction by the two sides of a triangle taken, see here, if two vectors are represented in magnitude and direction by the two sides of a triangle taken in same order, then the resultant is given both in magnitude and direction by third side taken in the opposite order, that is tail of resultant is coincident with tail of the first vector. Now see here, suppose this is vector A and suppose this is vector B. So these are two vectors. I can take suppose two forces acting on a body simultaneously. Then what is resultant one? That is obtained by triangle. So see here, so suppose I will take vector A here again, same vector here. So this is vector A, this is vector A, and this is vector B. So see here, let us take this point O and this point as P and this point as Q. So see here, PQ, that is B started from point P. Point P. Now what is resultant of these two? Now resultant of these two, let us call it as C. This is resultant of A and B. So here this is triangle. This is triangle. So here third vector, that is third side, that is C or OQ. That is tail of resultant. See here, this is tail of resultant OQ or vector C is coincident with the tail of first vector. This is also tail of first vector, that is vector A. Vector A. So this is called triangle law. Now here we take C is equal to vector C is equal to vector A plus vector B. So we have to take addition of two vectors, that is A and B. So first vector it is A, that is along OP. Then start second vector from point P, that is tip of vector A, and then take resultant of this from tail of vector A to end point of vector B. This is resultant and this is given by this equation. Vector C is equal to vector A plus vector B. Now see here, suppose we take like this. So suppose we take first vector B and then vector A. So we will see that. So here we will get what? Take vector parallel to B here from point A up to this. This is vector B. They are similar vectors parallel to B, and then take A. So what happens in this triangle? This is tail of B for this triangle. This is tail of B and this is tail of C. So in this case we can write C is equal to B plus A. B plus A. So you can write here A plus B is equal to B plus A. What is meaning of this? This means the vector addition is commutative. Vector addition is commutative. Vector addition is commutative. Now we'll go to second one, that is parallelogram law of vector addition. Here again we will take two vectors and triangle of vectors. Now here, so let us consider here, this is vector P and this one is vector Q. So these are two vectors. So I will take vector P here, same vector I have taken here, and from so let us take this as O. O is tail of P and A is tip of P. OA. Now let us take that Q vector and start it from A, and we will take this as B, this point as B. Okay. So this is this point A is tail of so this vector is Q. So here point A is tail of Q and tip of P or end point of P. Now what is resultant? Resultant is along OP. So let us call this as R. This is according to law of triangle of two vectors. So R is equal to, here we will get P plus Q. Vector R is equal to vector P plus vector Q. Now suppose we take vector parallel to Q and having magnitude equal to Q. So, and start from O. So this is also Q because they are parallel, also having same magnitudes. Again, take vector parallel to P and having magnitude equal to P. So here I can write this point as D. So see here, this is first triangle and this is second triangle. Now for first triangle, we have taken first vector P and then vector Q. For second triangle, we have taken first vector Q and second vector, this is also P. So here we know. So I can write R is equal to Q plus P also. Q plus P also. Because addition is commutative. Addition is commutative. Now here, let us extend this OA, length OA. So I have extended. Now draw perpendicular from point B on this extended OA. So let us take this point as C. This point as C. So this angle is right angle triangle. So this angle is 90 degree. Now here, see, what is this OA, what is this OC, and so on. Now we'll see here. BC is perpendicular to OC. BC is, so here we have BC is perpendicular to OC. BC is perpendicular to OC. So if we see here, OB, that is magnitude of OB, that is magnitude of R. So if we see here this triangle, consider right angle triangle OCB. For this triangle, we will get OB square is equal to what? OC square plus CB square. CB square. OC square plus CB square. So I can write OB square is equal to, now what is this OC? OC is equal to OA plus AC. So you can write here OA plus AC bracket square plus CB square. CB square. Now see here, let us take this angle as theta. This angle as theta. And suppose we take this angle as some alpha and this angle as beta. So what is alpha? Alpha is angle made by OB with OA. And that gives you direction of R with respect to P. Direction of R with respect to P. Now here beta. Beta, it is angle made by R with Q, or angle made by OP with OD. So this gives you direction of R with respect to vector Q. With respect to vector Q. Now see here, if we take a triangle ACB, this is right angle triangle. Now from this angle is theta, this it is OA. So here we get AC is equal to AB cos theta. For this right angle triangle ACB, for ACB we get AC is equal to AB cos theta, because cos theta is what? AC upon AB, and BC is equal to, or CB is equal to, CB is equal to what? AB cos theta, sorry, AB sin theta. This is, see, I am using simply geometry. AB sin theta, AB sin theta. So I can write here OB square is equal to OA square plus AB cos theta, OA plus, here OA plus AB cos theta bracket square plus CB square, that is AB square into sin square theta. Sin square theta. Now solve this. So we'll get here OB square is equal to OA square plus AB square cos square theta plus 2 times OA into AB into cos theta plus AB square sin square theta. So this we got. Now see here, AB square cos square theta, AB square sin square theta, that is AB square is common, in bracket cos square theta plus sin square theta. Cos square theta plus sin, that is 1. So we'll get OB square is equal to, so we'll get here OB square is equal to, Now if we see here, OB square is equal to OA square plus AB square from these two. So we get here OA square plus what? AB square plus 2 OA into AB OA into, here we have AB cos theta into AB cos theta. We got this from triangle. Now see here, what is OA and what is OB? Now OA, it is this length, that is magnitude of P. OB, it is equal to this length, that is magnitude of Q. AB is magnitude of Q and OA is magnitude of P. And what is OB? OB is magnitude of R. So we will take means here magnitude of R, let us write it as R, that is OB. Magnitude of P, that is OA, and magnitude of Q, that is AB. These are magnitudes. So you can write here R square is equal to P square plus Q square, these are magnitudes, plus 2 times magnitude of P into magnitude of Q into cos of theta. So this gives you square of resultant of P and Q. Square of resultant P and Q, where theta is angle between here. This angle theta. Theta is this angle. This angle. Means that is also angle between, so this angle theta. This angle theta, angle between P and Q, because P is along AC also. P is along AC also. So theta is angle between P and Q. Now we have to find direction of R. We have to find direction of R. First we will see magnitude. What is magnitude of R? Magnitude of R, simply I will write R is equal to square root of P square plus Q square plus 2P into Q cos of theta. This is magnitude of R. Now we have to find direction of R. Direction of resultant vector. How can we find? So here, see, alpha gives you angle between, means here alpha is angle between P, vector P and R. So this angle gives you direction of R. Or beta, that is angle between R and Q, that gives you direction of R with respect to Q. While alpha gives direction of R with respect to P. So you can find by geometry of this figure. So here, see, we can take triangle OCB. So from triangle OCB, what is tan phi? Tan alpha. Tan alpha will be equal to, now if we see tan alpha is BC divided by OC. This gives you tan alpha. So BC divided by OC. Now you can write tan alpha is equal to BC upon OA plus AC. OA plus AC. OA plus AC. Now what is BC? This BC. This BC we have taken AB sin theta, and AC we have taken AB cos theta. So here BC is equal to AB sin theta upon OA plus AB cos theta. So we'll get tan alpha is equal to AB means that is vector Q. So Q sin theta divided by magnitude of vector Q divided by magnitude of vector A, that is vector P, that is P, plus Q sin theta. So what is alpha? Alpha is equal to tan inverse Q sin theta upon P plus Q. Sorry, here we have cos theta. Here we have cos theta, not sin theta. Here we have cos theta. Cos theta. So Q cos theta. So this is angle made by R with P. You can find beta also. You can find beta also. So how can we find beta? Simply here. Extend this in backward direction. Draw perpendicular on this. And same. Use OD and we can take DE. And from this you can find beta. Same याच्या सारखं वापरायचं. So from this you will get simply beta will be equal to tan inverse of P sin theta divided by Q plus P cos theta. Tan inverse of P sin theta upon Q plus P cos theta. You will get this. So in this way you can find direction of resultant vector. So this is about parallelogram of two vectors. And this is for addition of two vectors. Now we'll see simple example. Let F1 and F2 be the two forces, vector F1 and vector F2 be the two forces 10 Newton and 6 Newton respectively acting on the body at a point with angle 60 degree between them. Find the resultant force and resultant direction. Resultant force and resultant direction. Now how can we find this? How can we find this? So let us take suppose here body is placed at point O and we have here F1 force acting and here F2 force acting. So F1 is acting along this direction, F2 is acting along this direction. So they are not collinear forces and angle between them is 60 degree. So what is resultant force? So to find resultant force we can use parallelogram method. Parallelogram method, parallelogram of two vectors. So here, so let us start from take vector parallel to F2 and start from this. Then this one. This is parallelogram. Now we have seen this. Suppose this is resultant F, resultant force, and we have already seen for vectors P, Q. So this is F2. We have seen resultant vector R, it is P square, square root of P square plus Q square plus 2PQ cos of theta, that is angle between them. So here theta. So I have taken parallelogram. Here in place of P we have F1, in place of Q we have F2, and in place of F we have R. So we get here F is equal to resultant force will be equal to F1 square plus F2 square plus 2 times F1 F2 into cos theta, 2 times F1 F2 into cos theta. Now, so here we will see what is F. Now theta is what? Theta is 60 degree. Theta is 60 degree. So what is cos 60 degree? What is cos 60 degree, Aman? Hello? Cos 60 degree.
1/2, sir.
It is 1/2, 1/2. Okay. So we'll find resultant force. So F is equal to square root of. Now here F1 is what? 10 Newton. F2 is 6 Newton. So we'll get here 10 square plus 6 square plus 2 times 10 into 6 plus into cos 60 degree, that is 1/2. So these two will get cancelled. So F is equal to square root of 100 plus 36 plus 60. So you will get F is equal to square root of, now 100 plus 36 plus 60. So you will get 196. So 196 means this is what? 14. This is 14. So 14 Newton. So this is resultant force. Resultant force. Now we have to find what? Direction of resultant force. So you can take this direction as alpha. So we know tan alpha is equal to, we have seen that is F2 sin theta divided by F1 plus F2 cos theta. We have taken Q sin theta upon P plus Q cos theta. Only in place of P we have used F1, in place of Q we have used here F2, and resultant is F. So we get here, now we will get here F2 is 6 sin 60 degree. Now F1 is 10 plus 6 cos 60 degree. Now we know this is 6 into root 3/2 upon 10 plus 6 into 1/2. Cos 60 is 1/2. Cos sin 60 is root 3/2. Now 2, 3. Here we will get 3. So tan alpha is equal to 3 root 3 divided by 10 plus 3. 10 plus 3, that is 13. So what is alpha? Alpha is tan inverse 3 root 3/30. So this is what? Angle made by F with respect to F1. You can find this angle also, beta. Angle made by F with respect to F2. And what is that? So you can find that as simply, so I can take here that. So here that tan beta. For that purpose, we have to take this in backward direction. We have to draw perpendicular here. And we get here tan beta is equal to F1 sin theta upon F2 plus F1 cos theta. Use same one here. Now here we will get tan beta is equal to, now here tan sin 60 degree upon 6 plus tan cos 60 degree. Now sin 60, that is root 3 by 2. Root 3 by 2 means here 2 will get cancelled. So here we will get 10 into root 3 by 2 upon 6 plus 10 into 1 half. So we will get here 10 root 3 upon 6 plus 5, that is 11. 11. And इथे 2 जाईल नाही का 5 येईल. Here we will get 5. So what is beta? Beta is equal to tan inverse 5 root 3 by 11. This is angle made by F with respect to this F2, and alpha is angle made by F with respect to this F1. So in this way you can find direction. You can find direction. Now we'll go to addition of vectors, but here we have number of vectors. Means I can take here vector A, vector B, vector C, D, E, like this. So these are number of vectors, and we have to take addition of vectors. This is called polygon law of vectors. This is called polygon law of vectors. So how can we take? So let us take first vector A. So I have taken this vector A here. And suppose this is tail of vector A, that is at point O. And this is point P. Okay. Now let us take second vector. I will take vector. Now here I will give notation. This one I will call B. So the vector that will come here, I will note that. So let us take this as vector B. Vector B. Now let us take use law of addition of vectors. So resultant of these two, let us take this as R. What is R? According to law of triangle of vectors, that is vector A plus vector B. Vector A plus vector B. That is resultant of A and B. Now let us take third vector. So this is third vector. Start from tip of P. So here C. C. So now it is also started from tip of R. So you can use R and C to find resultant of these two. So resultant is this. I can take here R, Q vector. Now according to law of triangle of vectors, Q is equal to, now we have to take two base vectors. So that is vector R plus vector C. Now we know R is A plus B. A plus B plus C plus C. Now let us take next vector and start it from tip of C. So here I will take this as vector D. This as vector D. Now for law of triangle of vectors we require two vectors. So here see this point. This is tip of C as well as tip of Q. So you can use vector D and vector Q to find resultant of these two. So here this is resultant of these two. So R, Q, and now here I can write this as vector W. So vector W is equal to vector Q plus vector D. Now see here, vector Q is A plus B plus C. This is vector Q plus D. So we got vector W. Now let us take another vector and start from tip of D or from tip of W. So let us take this as vector E. Now to find resultant of W and E, first we will find that W and E, resultant of that. So this is now we know tail of W, this is tip of E. So resultant of W and E, let us take this as S. So according to law of triangle of vectors, S is equal to W plus E. Now we know W is equal to what? A plus B plus C plus D, and here plus E. So see here, resultant addition of number of vectors, it is given by polygon law. These are, so OP, you can give point here OP, O, P, Z, Y, then you can take here T, and you can take here some P, Z, Y, T, and here X. So these are polygons. So here resultant is what? Vector A plus vector B plus vector C plus vector D plus vector E, and resultant it is this one. And A, B, C, D, E have number of different directions. So in this way you can take addition of number of vectors and you will get resultant vector. So this is about polygon law of vectors. Now we will go to subtraction of vectors. We have seen addition of vectors. So suppose we have here vector A and vector B, and we have to take A minus B. How can we take? Means subtraction of two vectors. So here we know, let us take here, this is tail, this point means here this point, if we take this point is tail of vector B. Take another vector anti-parallel to B and having magnitude equal to B. So here this is vector, this is now anti-parallel to B, opposite to B, and its magnitude is equal to B. So I can call this vector as minus B vector. Now here we have two vectors, A and minus B vectors. So here you can take resultant of these two. resultant of these two. So let us call this as C, this as C. So here C is equal to A vector plus minus B vector. So here we will get C is equal to A minus B, A minus B, A minus B. Now here we know from suppose we take this as a vector D. So we know D is equal to what? A plus B for this first triangle. This is second triangle. Now see, let us take vector B, means vector parallel to B and start from tail of A. Tail of A. Let us take here. So this is vector B because its magnitude is equal to B and it is parallel to B. Now let us take vector parallel to A and start from tip of A or end point of A, end point of B. So this is vector A. So this is parallelogram of two vectors A and B, and D is resultant, and we know we can find resultant of these two. Now if we join this, means suppose this point is O, P, Q, R, S. So we will find OS will be equal to RP. So this one will be equal to C. So this one will be equal to C. Means here suppose we have two vectors, then corresponding means here vector A and vector B. If we want subtraction A minus B, then simply take third vector, start from tip of B and draw up to A, that is C, and this C will be equal to A minus B. For addition you have to draw parallelogram, and resultant diagonal of parallelogram, this diagonal, this first diagonal it is addition, this second diagonal it is subtraction. So in this way you can take subtraction of two vectors, means you can add two vectors, you can subtract two vectors. You can add two vectors and you can subtract two vectors.